Now live. So, welcome to the August Omaha Linux Users Group meeting. I'm John Larson, Systems Engineer at AIM Institute, or as we call it, AIM nowadays. Let's see, what's happened since the last time we met? Fedora. Fedora came out, that's true. I just finally upgraded my desktop this weekend. I already did my laptop. Not much difference. What's that?
Update.
Yes, a lot of updates. Was there any kernel announcement? I don't remember.
There was an announcement on the Linux kernel mailing list. You see Torvald's latest, you guys all suck routine?
Oh, no.
It was classic Torvald's.
Oh.
He's taking that whole be nice thing to as far as it's going to go.
Is this like the NVIDIA one?
It's close.
Oh, okay. Not as visual then?
No, not as many suggestions.
Ah, I see. Very good. Very good.
So Fedora 24 is end of life now, or is it a couple weeks from now?
It's usually 1 month after the release.
So if you're on 24, get off 24.
Yes. I need to do my Mythbox next.
Yes.
It's
OpenSUSE 42.3 came out, I think. New Debian 901, which is just a regular roll-up of updates and stuff. Some security patches. You see Bitcoin split?
I thought there was discussion of splits.
There are now 2 Bitcoins.
Did
Bitcoin, I don't know if it's officially yet, but it's Bitcoin Cash. So it's all fun and games.
Don't split your wallet. It'll be very difficult.
It's going to be very interesting how that all shakes, because there's a whole bunch of descriptions of fighting over how the wallets go, how the technologies go. Because once upon a time you were able to buy some of Bitcoin in a matter of seconds, and then now it's a matter of minutes. So there's this whole thing back and forth on it between that other.
Because the transactions take so long.
To hit the record and stuff, which is kind of funny because I'm all into zero coin and I lost a lot of money. But that's a story for that.
Not Dogecoin?
No, I thought zero coin would turn out to be decent because it had some anonymity features that were really nice. You didn't have to mix stuff already. It had 2 types of addresses, your public and your private address. Mm. But I guess wrong, really wrong. But that's enough stories of failure for me today.
Yes. You all heard my earlier ones. So
that's cryptocurrency. I actually had them mining it out at Genesis mining out in Iceland and stuff. So yeah.
Okay. Yes. Go ahead.
So we got the rest of the talks for us this year. Brian's responsible for next month. Then Adam's got the next 2 after that. Then you've got December. Mm-hmm. So I think we're good on talk. But we do still need speakers for some of the other sessions. So if anybody's interested, please volunteer. Reach out to him or Brian or whoever's responsible for it. The schedule's on the website.
Yep. In the spreadsheet.
Yes. Anybody else got anything else? Linux related? Sweet.
Okay. Aaron is going to talk about System Tap.
Yes.
Awesome.
I've been threatening to talk about System Tap for years, and finally the time has come.
Yes.
It's been on my list for ages, but let's start with the basics. What is System Tap? System Tap starts with a project named dtrace. Dtrace is a dynamic tracing framework made by Sun Microsystems and designed to be used with their Solaris operating system in 2005. Dtrace is ported to Linux in 2011. It's phenomenal. It has a whole bunch of features. What you do is you put markers in your code, and it can actually keep track of timing and figure out behavior based upon it, like I/O, performance, networking, all sorts of capabilities. It's really a nice tool. The PHP guys use on Solaris to speed their stuff up by hundreds of % in various parts and stuff like that, because it could do a lot of work for them and help them figure out a lot of a whole lot of bottlenecks, stuff like that. It's also been used extensively in the Java stuff. So dtrace is a really nice piece of software. So what is cool about it? It can be turned on or off programs without source. You don't need source code. It doesn't require recompiling or reinstalling the program. It doesn't impose a performance penalty when it isn't running. That's very, very nice. There's a millionth of 1% or something, but it has to skip past the markers for the most part. But it works really well. So it's just Very, very, very slight, because it's just
Doesn't
markers.
impose a penalty when it isn't.
Yes. Normally, when you think, if you compile something with gprompt, -g, debug, all that kind of stuff, you pay the penalty regardless of whether you're actually using it.
All the time tests.
Yes.
Oh, yeah, okay.
It still has to keep track of the dtrace does not. Theoretically, it's like a millionth of a 1%. So the question is, why isn't this talk about dtrace? Instead, why is this talk about system tap? Dtrace is licensed under the CDDL license. This is the same license that ZFS is licensed under. The only version of Linux you can actually get that comes with dtrace available is Oracle Enterprise Linux. That's because that's owned by Oracle, who now owns Sun, who now owns all that stuff. You can take the source for dtrace and add it to your own Linux systems, but you can't redistribute that version since the CDDL and GPL licenses aren't compatible. There are differing opinions on this, because if you look at it right now, Ubuntu, can you get ZFS with Ubuntu? The answer is yes. How are you able to get ZFS? Ubuntu has decided to ignore the licensing compatibility. It's funny because Stallman was just talking about this yesterday, I think, on the register, again, about how they're incompatible licenses. Because one of the things that BetterFS doesn't have right now is dedupe that ZFS does, which is a really nice feature if you have like virtual machines and stuff like that. So the CDDL license, the commercial distribution development license or something like that. It's a license that they license all of Solaris under, that's available under open source. It's just unfortunately has the requirements that are incompatible, depending on how you look at it. But given the licensing uncertainty, the System Tap project was started to create a system that would be similar to dtrace, but licensed under the GPL. So. Harmony, which have all existed for various purposes to try and recreate stuff that's under more strict licenses. There was original Project Harmony 1, which is an attempt to recreate Qt. There's Project Harmony 2, which was an attempt to create a replacement for Java that was under the GPL. But all these have been superseded by other projects. It would really be nice if this happened. Dtrace, it would be nice if it was available, but it just isn't for the most part. There have been some people working on it, but it hasn't happened yet that I've seen any regular distributions. How do you install System Tap? System Tap is available for almost all major distributions. For Debian, the following should work: apt-get install System Tap, apt-get install Linux image, uname-r, debug, apt-get install Linux headers, uname-r. You don't technically need the image and headers, but your tracing will be useless without it, because it won't be able to figure out where you're at in the code unless you're just going by your own markers. There are pages, one of the big people behind it right now is Red Hat's put a lot of money and time and effort behind System Tap. So they've done a lot of good work with that. So there's pages from Red Hat, how to do it. Fedora has pages on how to do it. Ubuntu has a site talking about how to do it. Arch also has some really good stuff to do it as well. One thing to keep in mind with Arch is it always strips the kernel by default when you install it. So you have to go through, do some wonderful magic stuff to get working with Arch. But it's not too bad. Linux Mint and Ubuntu don't offer the debug kernel, so you have to build your own packages, which is kind of a pain in the ass. I mean, it's just part of what you got to deal with for it. Yeah. What it really means is you really need to be able to debug the kernel, so you need the headers and System Tap and debug images. You'll also need GCC if you're using the C extensions, because you can do this really amazing stuff we'll talk a little bit about called Guru Mode in System Tap, which lets you actually install C code inside a running kernel, which is the way of madness. It can do some very cool things. So when you install System Tap, it'll usually create 2 or 3 groups inside your Etsy group. There's a Stap user, which is a group that's all you need to run a compiled module. There's Stap dev, which is a group to be able to build a compiled module. And there's Stap sys, which is a group if you're doing client server installs. One of the things you can do with System Tap is you can build the modules to be able to redistribute with your executables or other stuff, so people can just run that component without having to have the source code for it. It's very cool, but not a lot of people do it, and the Debian group really doesn't support it that well yet. For the most part, if you're going to play with System Tap, put yourself in the Stap user, Stap dev groups, and you'll be able to actually do about everything you need to do. Not every distribution creates these groups, but if it doesn't, you definitely need to create them. But Debian, Ubuntu, and Fedora all create those when you need them. So how does SystemTap work? This is a little behind the scenes. You create an STP file in the SystemTap language. This is converted to C by the STAP process. It's compiled into a kernel module, .ko module. STAP run inserts the kernel module into the running kernel. STAP run runs the kernel module until Control C or programmatic exit. So it doesn't exit by default. There's nothing that says get out unless you tell it to. And it removes it from the kernel when done. So how does it look to the user? You create a STAP script. You type STAP script STP, and the output from the script until you stop it or it exits. Really pretty simple. There are a lot of tools for bringing out the performance in your system. There's a list of a couple of them. There's perf, which is a performance monitoring tool. There's LTTTNG, which is Linux tracing next generation, which is kernel level monitoring. There's proc. Everything you need to know about a running Linux system is in proc somewhere. You just have to figure out how to get it out of proc. And the fact that it's there doesn't mean it's going to be necessarily easily to access. So all the data is there. There's various scripts and stuff people have written that will go through proc and figure stuff out, but sometimes that changes and the behavior is not necessarily always the same. So I think we kind of interesting. strace, useful for process trees. Most people use strace when we're trying to figure out why permissions, why something failed running, that kind of stuff. And there's a lot of other ones. You can compile your code with profilers, all sorts of wonderful stuff. But SystemTap seems to be a pretty good mix of functionality with a decent implementation language, and it's used by places like NASA uses it for their Lustre file system to figure stuff out. The PostgreSQL guys have used it. The MySQL guys have used it quite a bit. MariaDB has used it quite a bit. The PHP guys have used it. It's been used by a lot of different people over time. They can provide some very nice functionality to it. The Lustre one is very interesting because it's an example of what happens when you try and run something on a large set of scale. Because there you're talking NASA's running hundreds of machines running this kind of stuff, and just trying to turn it on each individual machine, trying to pull all that information together, trying to figure out how to plot it, to do all that stuff with it, it's almost impossible for a human to do it. So the fact that STAP lets you do it on and off SystemTap is very, very nice. So it's time for Hello World. Everybody needs to do Hello World. So it's not a bad idea to do Hello World because it proves that your system is running. Gives you a very simple thing. Let's fire one up here and take a look. Control++. So that's the whole of the code. Probe begin, bracket, print hello world, and an exit. You need an exit because if you don't have the exit, it will just never terminate because it's a dynamic probe. It's designed to hang around forever. So that's all you need for hello world. So let's run hello world now. Yay. And let me show you what happens if you do take that out. See, the language is very C-like. It's the way it was meant to be. Not exactly C, but close enough that it can do things. So now if we do... No, they're optional in it. But I've changed the module now, so it's actually recompiling in the kernel module now, so it takes a little longer to run. Hello world, and it's never going to end because I've just did the probe begin. There's probe begin, probe end, all sorts of events can catch and stuff like that. We'll talk about when we look at some examples. But it gives you a quick idea of how simple the language can work. Let me change that back so it's right again. So it harnesses pretty well to the kernel. Gives you a quick idea. That's the code again. And we have that one. So that's how would you fire it up. Let's use it to solve a problem right now. Let me show you a quick little piece of behavior on the system I've got set up right now. So Firefox. All right. So we're gonna fire up Firefox real quick, and we're gonna hit the OLUG website. And we're gonna do it again. I wonder if it's going to fire up quick. It's going to fire up quickly enough. Okay. It's going to fire up for a second, then it's going to die here. Unfortunately, we hit the cron right at the top. So now it's going to stay up probably for hopefully a minute or less. So I'll have to. What?
/1.
I just start. So now I talk while this does this. We go hit this real quick.
Pay attention to the man behind.
It better die. If it doesn't, I'm going to be very, very angry. So, Brian, Adam, John. There, it died. That was a long minute. That's all I can say. So what we have now is we have a situation where the system is killing Firefox every minute. We don't know why. Well, let's find out why it's doing that. There's two pieces that we're going to use for this. One is called sigkill. Let's take a look at that real quick here. Very simple. That's from. So, it's just a very simple thing. All it does is it looks for the sigkills, and it says who sent the signal and to what UID and stuff like that. So we now will be able to have that piece of information. So let's run it. And of course, we don't have anything happening right now because there's no output until something happens. So what we got to do is go over to another window and do Firefox again. And hope it starts before it dies. All right.
There you go. Let's pick up on you.
Yes. So now we have to wait a minute, which is going to be a long minute. I know, I can feel it. It's going to be a long one, for sure. But what it's doing right now is let's pop back over to our window where we have the sigkill process running. Let's look at that code real quick. So it looks for sigkill. This prints sigkill was set from process ID by user ID, sig name, and exec name. So now we just have to wait a minute, and it died. And we wait for the bell to go away. So sigkill was sent to Firefox ESR PID 43333 by kill all UID 1000. And if we look at UID 1000 in the system, that will be, it's me, but let's do it again. So I'm doing the killing of this, but I'm not exactly sure what's doing the killing, so we have a second program we can run. So we have that piece of information now, which is nice. We have a program called PS Tracing SDP. And this does a little bit more. This is a system tap overview sample. It goes through the tree and figures out what's actually doing the killing. So it actually figures out who is calling the kill at the top level. So now, if I run this, I should not have talked about strace because now I'm thinking it's okay.
Oops.
It's going to give me grief. I knew this was going to happen. It always does this. It should be.
So looking for that.
I believe it's looking for the guy. I thought I had modified this one already. Let's do PS tracing, SDP. Ah, there we go. It's running, it does provide warnings because that's the wonders of System Tab. This version's a slightly out of sync with some of the examples, but if we run it now, we should. Yep. Running on borrowed time, hopefully. All right, the rest cert real quick. We have a meeting coming up in August. Roy Bruckman from CyberArk's going to be talking about privilege account separation, since I got a minute. And it died, which isn't what we wanted. And
Because it was lowercase. Sensitivity.
It should be running. It should not need that. Let me try that again.
Did you create the demo back?
I'm trying to think of what I've changed since I did the demo last. The demo was working just fine 2 days ago, and I was working on it, finishing up. We'll give it a minute, literally and figuratively. All right, I'm doing something wrong with it. What it would normally tell us in an ideal world, yes, it is interesting. Come on. See if I got something different than I think. So, what it'll normally tell you, if you do it correctly, is it'll tell you UID 1000 and tell you cron is what's doing the killing, because it's doing the trace to tree correctly. I don't know what I'm doing wrong with the demo on that. I knew I had to save it somewhere in my notes too. All right, so you would normally see cron, and if we go out and take a look at cron tab.
Report the possibility of the system.
If we go to cron tab-E, we will see there is a script at the bottom of the cron tab that kills kill all -9 Firefox ESR. And then if you were to comment that out,
How did it know it was embarrassing?
I don't know. Sometimes it wants to hurt me.
Yeah.
Linux loves you, but sometimes it doesn't. Now we'll just do a sleep 60, and we will let it go for 1 minute to make sure that it actually stays up beyond a minute. So that's one way to somewhat get control of the system. But it just tells you, it can give you some information about what's killing a process and stuff like that. It can do some very cool stuff in that component.
Assuming it's up to date.
That is an issue. That actually is one of the reasons why some of the kernels and stuff like that, it can have some issues with it.
Do they frequently have to do a research every kernel release, or they might just make changes?
Yes, this exists outside the Linux kernel. It's not part of Linux kernel currently. And odds are it will never officially be part of it. But since it is part of the Fedora stuff, it tends to be pretty well in sync with them and stuff like that. Debian isn't as friendly with it. Example being the client server stuff. Debian does not tend to work with that too well and stuff like that. But as running on one individual system, it can do some very nice stuff. It's staying
a very dangerous step.
Yes. But actually, talk about the website real quick for it. System Tab has its whole own wiki out there. It has one really nice section called War Stories, which just talks about various implementations and how they've done things with it to make it go better and stuff they've done with it. One of the things they've changed in it is normally when Linux kernel runs out of memory, what's the behavior for it? Kills a random process and hopefully keeps going from that. One of the things you can do with it, there's a option on here called panic on out of memory. So you modify the behavior just this much. What it does is it will panic the kernel. So we'll shut down the whole system, write a core, and you can actually get the core and actually ship that back somewhere. Yeah. So you can do some behavior like that. So you can change the way the system works overall. A whole bunch of different capabilities and stuff like that that you normally don't have with the kernel. So it can give you stuff you never thought about. But War Stories, people have done some very interesting stuff with this. One of the ones I thought was really interesting was the oh, there's all sorts of stuff in there. GNU plot, people love monitoring that.
Can you use this thing to track down a row 500 gigabyte file? Like an error log or something?
Well, that'd be, if you knew when it was writing it, yeah, you could actually have it keep track of how big each file gets when it starts writing. They can keep track of when a file is running and how much data has been written to it, stuff like that. There's some stuff in the networking that could possibly lead into that.
Yeah, I had a 500 gigabyte error log file one time, and it was shouting off warnings at me, so I tracked it down.
Yeah. Yeah, I mean, it's still there. You're better off with DU and stuff like that. It's more for dynamic tracing type stuff. If you had the problem happening recurrently, I mean, recurring all the time, then something like System Tap could be really useful for that. But
I ended up setting that file to read only after blanking it.
So now I've made the change, so now everything is hunky-dory with it. So that's a small non-working example. I can write a much larger working example as well. It shows you a bit of the powers available for System Tap. If you install it, System Tap docs, you'll have access to some other examples under the user share or System Tap doc or similar directory structure. It's broken out into various sections: memory, I/O, network, games, process, profiling, virtualization, and there's some other ones as well. There's a whole bunch more examples available in the System Tap wiki. Let me, oh yeah, this is one I get asked. Isn't System Tap dangerous? System Tap tries to be friendly to the system. It has internal limits. It will hopefully not monopolize all the memory, CPU, disk on your system at one time. They put various checks in it saying don't go above certain thresholds and stuff like that, but if you're at a point where your system's on the verge of keeling over, this might just be enough to just add the top to it. So it does add up to, there's some stuff in there. One thing to keep in mind in the past, and I'm sure in the present, there have been privilege escalation bugs in System Taps. If you're running with quite a few privileges, you're able to intercept systems, you're able to do stuff, and that theoretically could lead to the possibility of privilege escalation, root type stuff. I would not recommend shipping to someone on an internet-facing system. It's more what you want for your internal lab, that kind of information, but it can be very, very useful for that. And we're going to be talking a little bit about a mode called Guru mode. Guru mode is really dangerous. I mean, it is everything you would hope and imagine it would be, unless you do things that you should not really want to do. So let's take a look at some examples under the System Tap. Oh yes, it is phenomenal. The minute you can start putting random C code into your running process, come on, you're there. So let's start with Snap Games, because that's where everything should start.
Global thermonuclear war.
It doesn't have that one. You can be right. So it's just a simple game of life, like always. It only shows the capabilities of the language. So it's a couple simple screens of information, but oh,
your terminal's not working.
oh, is that the problem?
That's my guess.
Could be. or just maybe one that's not going to work on here. That's one of the great things about the examples. Not all of them work, which provides you very valuable information. Your mileage will vary as each one goes. But let's take a look at one that's actually kind of interesting. IO. And there's IO top. And let that run in the background. Let's fire up another session real quick. I'm trying to figure out, this is one of the ones that's, there we go. It shows you who's reading and writing code every 5 seconds. Just provides you the amount of kilobytes of data going in and out, all that various information. Firefox isn't using anything right now, but it just maps it out for you. What makes that interesting is you can actually change the behavior of it. It's not like you can go out and grab an IO top, obviously the executable, and install it on your system. This just provides the capability to one that you can modify. You can say, I don't care about these processes, or I do care about these processes. Any of that type of behavior. And in 27 lines, it's able to figure out based upon intercepting the virtual file system stuff. So given the fact that it works with that, it'll work with any file system. It'll work with ZFS, it'll work with XFS, it'll work with ext2, ext3, ext4, BetterFS, any one. Quite a bit of capability there. There's also inode watch, which you can tell to watch a certain inode whenever that is accessed, when something is happening to it. If you're finding behavior, something's happening, like you want to find out what's writing to your log file, you can figure out the inode, you tell it to watch it, you can figure out which process are connecting to it, then you can start modifying the behavior of that. There's eat my data, which is phenomenal. Just concept is just random, it just eats the stuff you're doing. It's another version of dev null pretty much, but yeah. But one thing about it is, a lot of these files will have a .text file that provides an example of what in the world the output will look like. Some have meta files to provide information or provide data with them, but it just goes back to the whole information in there. Yeah. So it provides a whole load of capabilities there, but there's that, there's it can do some pretty amazing things. The thing about it is, all this stuff that's been exposed is all laid out in documentation. The documentation has a beginner's guide, which has a lot of good information, and it has a tutorial, which will get you through hello world, basic stuff running, and that kind of information. So it provides quite a few capabilities there. One of the ones that actually is really useful is the NFS stuff. If you're in a situation where you're using a NetApp using NFS, it can provide you a lot of feedback about what's going on, what's going right, what's going wrong, and that kind of stuff. Which one's the one I was really liking? Which one I really was playing with earlier? NetApp? There's the one. But some of these, also keep in mind, you have to read the documentation for them, because some run every 5 seconds, some run cumulatively. I don't know if this one runs every 5 seconds or just runs when you control C and it finishes up and keeps track of all the stuff internally. I'm not sure about this one. We'll give it 5 seconds. 1 pin kilohertz, 2 pin kilohertz, 3 pin kilohertz, 4 pin kilohertz, 5 pin kilohertz. It is probably a cumulative one. And nothing's going on in the network right now because I don't have anything going on, since everything's local. But it gives you a whole capabilities there. One of the ones that's kind of interesting is the virtualization stuff, which is just to keep track of various information from QEMU and stuff like that, how the I/O is going, stuff like that. Locks, eventually if you start dealing with the kernel at a lower level, you'll start having issues with that, and you'll actually have to figure out what's doing locking and stuff like that. It can be really useful for that. But just to give you an idea, the important thing about it is, once you're in the staff user, staff dev accounts, you can run pretty much any of these. And there's really they're all designed to be safe, so you're usually all right. There's documentation for some. If not, go out to the sourceware thing, and it will tell you a lot more information. There's a million of them. There's a lot of them out here. But I mean, things like, which one was the one I liked? UDP fragment loss, based upon people having stuff happening. I think the guys who are doing this were doing something with multimedia, and we're getting behavior, so they're figuring stuff out. But whenever you run into a problem, you think there's something that might be useful inside it, there's more than likely somebody's already had that problem with this, because it goes back a number of years. Let's see which one else I liked. Yeah, self-built kernels, live CD, live USB, which actually the live CD USB is very nice if you want to just figure it out and just fire it up in QEMU and just, or VirtualBox and try it out for a while, because it has everything installed for it. Some of the applications that have been built with user space markers, PostgreSQL, MySQL, Mozilla, Perl, Python, Java, Ruby, libvirt, QEMU, glib, all of them have. One thing to keep in mind is you can add your own markers as well to your code, so you can actually ship them. So the example being the way they're laid out inside PostgreSQL, they're laid out in terms of the open, locking, reading, writing, memory, that kind of stuff. So you're actually able to figure out what the timing is and various pieces of information made available to you. So if you have a query that's running really horribly, you can start turning the markers on and figure out why it's running, where it's doing badly, what problem was happening. That can provide you a lot of information, provide back to the vendor and stuff like that. But, yeah. Guru mode. There are two things that people tell you about kill on a Linux system, on a Unix system, depending on how old you are. They are, there's two signals a process cannot ignore: sig kill, kill -9, and sig pause. We're going to change the behavior so kill -9 will no longer kill a process. And that's pretty amazing capability to do that. So the first law of Unix, well, the second law of Unix. First law of Unix is everything's a file except when it's not. So that we'll break that. So Guru mode allows you to break a lot of rules. It gives you a lot of capabilities. One of the goals with System Tap is they're adding more and more functionality, System Tap all the time, to theoretically be able to remove Guru mode at some point in the future. They want to be able to have at the point where everything you need to do, you can do without Guru mode. But I don't see how you're going to be able to do something like this. I think, yeah. So they're hoping to remove, but they haven't. The program is actually called Immortal STP. So let's fire it up. This one I know will work because I've been running it left and right lately. So. Let me just quick show you the code for Immortal. So that's throw it away and just print out a little statement saying it's happening. So let's go ahead and run it. Stat immortal.stp. So it's running now, and what is? There's no, that's a good thing, because it's not supposed to run this way because I'm running without Guru mode, which you invoke by -G. So now stat -G immortal STP. Come on. Nope, you have no sudo needs. So we have it running now. So since we've already been picking on Firefox, let's kill Firefox one more time. Yes, mycf, rep. Firefox needs, it dies by its own, so it's not really like you're just doing anything bad. It's kill -9, 5716. And it stayed up. It is ignored that. Yes?
It only does 9, it doesn't accept turn.
No, well, you would have to write more code for that. I mean, it's not hard to write the code. I mean, you can just, yeah. So if we look at that, Immortal process captured it, and process 5716 is immortalized from the puny process back. So that came in the code. I didn't write that because that is that corny. But that gives you the capability, an idea what it does. So if we were to be running on, if you've ever run on a system with other people, you know that's the majority of your problems are going to be, and more people have run on systems. They will -9 eventually now and then just to get their processes to run faster and stuff. So let's turn that back on. Let's leave the killer, turn the process back on. The killer process works again. So now we sit here for a minute. So there's more than one way to fix this problem. One way is to actually go through fix the cron tab. The other way is to do it this way. Which way is better? That probably fixing the real problem is the better way to do it. But is this way, in its own way, satisfying? It just got a kill signal and it ignored it. So we could have fixed it either way. So that's one way to fix it. If you can't get to the cron tab entry because your other program doesn't work when it should have, I still want to know why it didn't. But that's.
It doesn't tell you that it was cron tab.
No, it just tells you what the process was that kills it. We would have to use that process kill thing, which didn't work for me. But that was, I mean, you have to figure that out based on that. Yeah, so it doesn't give you that piece of information, but you can figure out through snap and trace and other components like that and stuff. But one of the things that some people would do is you can actually get additional process information. The process information is available, so you can chase it back to the tree and all that kind of stuff, but it gets into a little more interesting stuff then. But all the information is available. Pretty much, it exposes a lot of prop to you. So you can figure out the calling tree, the references, and that kind of stuff. I mean, it'd be a longer version than just that 8 lines of code we have there, but they can do it all the stuff. All the information is available for it. Yeah, but so now if we kill the process that immortalizes, and we wait a minute, we'll see it actually die again.
Should have gotten some music.
I should have brought the Jeopardy theme, but I can't afford the Jeopardy theme. That's probably way too expensive.
Sounds bad.
There's several versions of Girl from Ipanema.
I actually saw a question about that a while ago, and where Ipanema was, and I didn't even know the answer to it.
Brazil.
I thought it was Costa Rica. It might be Brazil.
But it's Brazil.
Oh, I got it wrong anyway. So I just thought that, it's like, I just thought it was Ipanema was Ipanema. All right, come on, you can do it. You can die. You can die. There it is. Firefox died again because we turned off the immortalizing process. But that gives you capability, an idea of what you can do with it. You can have it do other components. You can have it track stuff down. But the most amazing thing about Guru Mode is it allows you to stick code, C code that will be dynamically put into a kernel module. That means everything is available to you at that point because you are able to own the system pretty much if you're running Guru Mode. There really isn't a good way that I've seen to restrict Guru Mode. There's not like a separate group or anything like that for it. What you would want to do is you'd want to have people in the staff user group only and have to precompile the modules so they would be able to run them in a higher mode. But the ability to dynamically do that is phenomenally powerful because you can change the behavior of the whole system at that point. You have access to the whole everything, the whole enchilada. But so using System Tap and Guru Mode, you're able to break one of the primary rules of Linux, which is pretty interesting in its own right. Yeah, that example is pulled from the War Stories page from the Immortal program, but this gives you a rough idea of what it can do. There's all sorts of other capabilities to it. It has a huge amount of features it makes available to you. There's several pitfalls. I should put the other one in there that you'll have the parameters wrong as well. I didn't put that one on there. That's one of those ones I figured leave for John to bring up. You have to make sure you have the headers and debug installing your system. If not, it's going to give you weird behavior. Make sure you have the right headers and a debug installed as well. That can be very interesting. Read the documentation for the examples because some require parameters, won't work without them. Some will do different behaviors depending on what parameters you send to and stuff. Not all of them are written the same level of quality. And don't expect them to come back with something like, you need to pass this 3 parameters and 2 have to be this and 1 has to be this. A lot of those programs are just bah. So that's the way it goes. There's an optional package on Debian and Ubuntu and stuff like called the System Tap Client System Tap Server packages. That's for actually being able to distribute System Tap packages to other people to run and stuff like that. Don't install unless you need it because once you install that, it defaults everything you compile on there to trying to build in a client server environment, and you have to pass additional parameters back to get to behave the way you normally expect it to. If you just want to be able to debug a kernel and figure out what's going on, don't deal with that. If you're actually shipping this with your code, then you want to figure that component out. But that also goes back to the point that is not as well supported on Debian, especially. as it is on some other systems. The Red Hat guys have it pretty well defined, but a lot of them don't have it that well defined yet.
Question on that.
Yes.
I don't know if you're going to cover this, but you're obviously running this as your user.
Mhm.
Does that mean any user, is it like SG root for everybody? Everybody can run it?
No, you have to be the staff user, staff dev.
Okay, you have to be in that group.
Those two groups, but the power available to them is pretty much almost unlimited in that respect, because you can get back to guru mode and you can start running kernel code inside there. So,
Yeah.
So yeah, but I mean, it has its own, it brings its own potential risk with it, but definitely make sure to put yourself just into the people you need inside those groups to be able to run this stuff. Staff user is actually pretty useful in its own response. If you just want to be able to let people run stuff when they're running out in debug mode and stuff like that. There's some advanced capabilities we won't really talk about tonight. The client server stuff, we talked about that a little bit. Because you can compile the scripts and then deploy them to other systems. That's pretty interesting. If you are doing something like PostgreSQL or you have a custom piece of software, you can actually ship these with them and say, hey, run this, they'll give us additional information that you can send back to us so we can interpret and figure stuff out there. There are Python, Perl, Ruby libraries to make it easier to parse the results and provide some additional capabilities and stuff like that are pretty good. There's a GUI available for system tabs. You have to compile it from source. It hasn't been updated in quite a few years, but it has some nice features in there. It just dumps all this stuff into a screen. You can do stuff with it dynamically. I mean, everybody loves a GUI. How can you not? GNU plot. How many people have used GNU plot? Just me. All right. GNU plot is the classic GNU package for plotting data. It really is pretty simple. I mean, it has its own little language. You throw the information at it, and it'll do various things with it. Lots of people do this with System Tab to get pretty pictures because it gives you makes it pretty. Everybody likes colors and pictures and charts and stuff like that. You can also just dump the data into a CSV and then port it into Excel and do anything you want to with it there. System Tab with Guru Mode supports embedded C code copied directly into the kernel. I know I said that like several times, but that whole concept of being able to actually just add code to the kernel while it's running through C just seems amazing to me at times. I mean, don't get me wrong, you're gonna crash the kernel a lot, but the fact the capability is there is pretty cool in its own respect. But it can, yeah, but in terms of what it's been doing, it's been around for quite a few years. System Tab enhancing your programs. If you actually are writing programs that actually do have performance type issues and that kind of stuff or potential, dtrace has a concept of markers. Right now, when we go through, we're either doing it by signals or by process, by function name, that kind of stuff. And we're not always going to have the function names available to people, especially if you ship a strict kernel. You can put something in there called markers. And a marker is a very nice little thing. It says like, interesting stuff starts here, interesting stuff stops here. You can have people turn that on and off dynamically, and they can start getting information like, it spent 20 minutes inside this part of the code, or spent 5 minutes in this part of this code, and start putting pieces together and stuff, start exposing it to people. So it can be really nice for that component, because it provides a much easier interface for regular users to use versus having to know what all the function names are and all that kind of stuff. MySQL can be built with the markers. It has roughly 200 of them, mostly for operations such as open, close, read, write, etc. So it can figure out what's going on, because I mean, obviously a database cares a lot about the file system, how all that stuff works. You can start figuring out timing and stuff like that, and figuring out how stuff's working in the memory in terms of how it's utilizing it, all sorts of stuff like that. Yeah, so if you do add them to your code, you can get a lot of additional stuff. The MySQL guys did it, and then the Drizzle guys ran it for a while. Drizzle was this really interesting project which tried to make a cloud-capable version of MySQL. They took out all the complicated parts and just made a really simple, fast database for the cloud. And most of that's been folded back into MariaDB now, but it's very interesting. So for a program the size of MySQL, it's roughly 200 markers. So you figure for your stuff, average code, I'm thinking of a company in town I know that's got some programs that run that would probably have 100 markers or something like that in for their memory mapped database type information stuff. It'd be very interesting to see how they go. Yeah, PostgreSQL already has these. Let's actually go to. Oops.
Did comment out the Firefox.
Yes, Firefox should live again. No. It's thinking. It's probably trying to load up. Oh, it's loading Conquer. Oh, that's nothing better than that.
How many copies of Conquer?
All of them.
Yes, all the copies. Give it a second here. Come on.
The other window.
Well, that's 4. Yeah. Oh, nice. I'm killing some. Oh, there's a lot. You know, if I had system tap running, I'm gonna have to keep track of every time it starts. That's one thing to keep in mind with system tap. Actually, it can capture a process getting started, so it can actually prevent multiple copies of something from running as well.
Then it could tell you what's trying to window on you.
This is clever as all those Windows boxes that pop up.
I don't care what window bomb like that, since that's top you can smack it off window.
Come on, baby, you can do it.
Pick the wrong link and stop stuff. Control W.
I'm really thinking about modifying that sig kill.
Well, why not? Go ahead. Can't you go to a command line to say kill all Conquer?
Yes, I could, but that would be. I'm a masochist. I forgot that. All right, so we have a window open with the data.
Mounting video icon.
Yes. So they have transaction start, commit, abort, query starts, query parsers, rewrite plans. This is what they consider to be the valid checkpoints on it. So gives you an idea how they've got it laid out there. The two-phase commits, the buffer reads, all that information is available to you. So all that becomes available to the through the markers through system tap, so it can figure a lot of information out based on that. That just gives you a quick idea, but they don't compile it in by default because I don't know why they don't actually. That's one of the questions that always I've had about system tap is why it's not in some places used more. But you can enable your own programs with it. You can add additional capabilities to it. A lot of the big ones do it. The one that was kind of interesting that had it was the Java stuff. They've had some very interesting behavior based on that. They figured out what various points are in that. They actually use that to help decompose stuff down to their new, more modular versions of Java, stuff like that. It exposes some very cool stuff. But it gives you an idea of kind of figure out, if you're writing a big program, odds are you probably know more or less where you would want to actually be able to do that kind of stuff with. There we go. Yeah. So where this is at, other operating systems, FreeBSD, NetBSD, and Mac OS all have dtrace available. Ubuntu could theoretically make dtrace available because they've already bitten the bullet on the ZFS. They've said that there is no licensing conflict there, which there's still a debate back and forth on. So there's really no reason why they couldn't include dtrace in that as well. Do you really need it compared to System Tap? They have some differences, but for the most part, I mean, System Tap seems to be a pretty successful superset of it nowadays. Oracle Linux, like we mentioned before, has dtrace available. Solaris, of course, has dtrace available. There was a project with System Tap on the BSDs. It looks to be dead at the moment because I think they realized, hey, that'd really be kind of interesting to see how that would work. To add the capabilities where you're just mapping the System Tap calls to dtrace calls wouldn't be that tough, but to actually add all the capabilities behind System Tap behind to do things like the dynamic kernel modules, Guru mode, all that kind of stuff would be really kind of tough. Dtrace works really well for the markers and keeping track of stuff, but for doing the actual change in behavior, the operating system System Tap seems to be superior in my usage of it. The website we hit before, sourceware.org/systemtap. There's a lot of great stuff in there. System Tap is an interesting project. It's one of those ones playing around with it, and you find it to be kind of interesting how it works and does stuff. Another project that's starting to use SystemTap is Docker. They're using it to try and figure out how their behavior is working in various places, so it's going to be kind of interesting how it goes on there. It's available on most Linux versions. There's a version for Gen 2, there's a version for Arch, there's a version for Ubuntu, there's a version for this. You may have to recompile your own kernel. You may have to work for it. So it comes down to it. It's been used by a bunch of different groups like we were talking before. There's a really good talk on YouTube. If you type in SystemTap and Luster FS, they talk about how they were going through the process of figuring stuff out. They used it to figure out certain small writes were taking them 30 minutes to perform because of the way it was behaving, and they were able to remove some bottlenecks that way. It was really impressive. So I went through the whole thing. It's like an hour long, but it's really definitely worth it. Yeah, if you have a custom app you run, it can teach you a lot about performance, can expose a lot of capabilities to it. It can let you change the behavior of the system when you don't have access to the source, which is a big thing about it, because a lot of people would like to get more information from their customers about how their program is running, and that information's available, but they don't want to provide the source code. They don't want to provide this, they don't want to provide debug, they don't want to do that stuff because they consider that to be trade secrets. With this, you do just expose that capability, so they can just go through, figure out the markers, and you can have them run additional reports and stuff on there, and you can also figure that out. SystemTap's been around for over 10 years, so it is pretty well understood. It's evolved a lot in the first umpteen years. It seems like right now it's in a little bit of a lull, but there's a lot of capability still going on with it. Like I mentioned before, there is a really nice beginner guide tutorial for it. If you look at the SystemTap doc folder, there will be an HTML folder index which has all the examples laid out, a little bit of information behind them. And the SourceWare homepage has pretty much everything you need. Some of the links, sourceware.org/SystemTap, it's the website. Latest information, the wiki is really nice, it's really well laid out. Access redhat.com, Red Hat's documentation website. If you search for SystemTap, it'll have some really nice little demos and stuff available. That's where that non-working SIG kill came from, so maybe their problem more than mine. SlideShare, P.O. Sullivan, monitoring MySQL with D-Trace SystemTap. Example how to SystemTap your own programs. Really pretty nice little one. This guy doing the drizzle type thing with it. Once you install the SystemTap doc, you'll have some examples in the indexed HTML for examples. Really pretty good. Hopefully all those examples work in your system. That's not always the case, but obviously you're not paying anything for it, so your mileage may vary. But it's definitely worthwhile to figure out which ones are. It should give you questions that you are able to hopefully answer better by using these, like what's going on in my I/O, what's going on in my networking, that kind of stuff. And if you do have things like a NetApp, you're running the NFS stuff, the NFS queries they already have laid out can really be quite helpful for you. So that's all I've got. Does anybody have any questions? It can do some amazing things. Yeah, you can probably screw somebody.
I mean, here's the universe.
Yeah.
Yeah, you definitely don't want this to be exposed on all systems. I mean, this is
USB random house thing.
both. You know,
You
well,
don't need the USB thing.
well,
Little script.
that's one of the things that actually I think we need to talk about sometime. Is there's a couple tools out now. There's a USB guard which can actually do some, which actually is part of the Red Hat 7.4 beta, which can actually intercept USB calls and actually prevent whitelisting of things like mice and stuff like that. And just not to allow other things in the system. Won't do anything to USB kill. Which, everybody know what USB kill is?
No.
It's a USB stick that is nothing but a bunch of capacitors on it. What it does is it drains power from the USB port until it maxes out the voltage of the capacitors. Then it fries your USB on the computer, just dumps all the voltage back the other way.
Oh, that sounds cool.
It is.
Kills the system.
It kills, and it will destroy the USB on the system and takes out almost any system. There's really no way to prevent it from going because it just dumps power to it, but it's just a bunch of, they come in various sizes. I mean, some are a little bit bigger than a mouse plug, but all they are is a bunch of capacitors, and they just, and they're getting what it is. So it does that. And what does it do after that? If the machine's still alive, it starts charging again. And it does it again. It will do it over and over again until either the machine quits sending it power or the stick burns out. They're only like 30
I
bucks.
love your thought process.
30 bucks?
Yeah, they're like 30 bucks that I saw on Alibaba. So well, it's not that tough. You can build your own. It's just some faster.
I mean, but who has time?
You hear about that and your first reaction is, oh gee, I won't, how much did it cost? Well,
Because that's mail fraud, yeah. When you start getting across with that stuff, but it's some very cool stuff. But USB guard won't do anything. Now, USB guard will prevent people from sticking in USB sticks that aren't recognized and stuff. So,
It's pretty cool.
there's a whole bunch of stuff. But System Tab itself, if you do play around with it, come up with anything, there's a whole, the community on Sourceware is still pretty good and stuff like that. And there's a lot of good information about it. If you do have performance issues, it can tell you a lot of stuff. I've learned quite a bit playing with it and had some fun.
Awesome.
I'm done.
Hooray!
Thanks for watching. Goodbye.